Welcome to Miss Felchner's Math Corner on YouTube. We're in 8-1 Common Monomial Factors on page 200 in the Orange Book. The two objectives here are to find the greatest common factor of two or more polynomials, and then to factor polynomials using the greatest common monomial factor. See? Okay? Alrighty, so find the greatest common monomial factor. So right here, we have got 4m squared n and m cubed n. The first thing you're going to do is find the GCF of the coefficients. So the coefficients here are 4 and 1. The GCF of 4 and 1 is going to be 1, okay? Then you do the greatest common monomial factors of m and n. So first I compare the m's. So we have m squared and m squared. That's going to be m squared. Then we have n squared and n. So n squared and n share only one factor in common of 1n. So my final answer that I got was m squared, and obviously there's a 1 in front of it. You don't have to have the 1 there because it is implied. All right, now let's do the greatest common factor of 6a cubed c, 12a squared c squared, and negative 36a cubed c. This negative we don't have to worry about quite yet. We're only doing it kind of like the absolute value. So there's no negative or positives there. So first, what is the greatest common factor of 6, 12, and negative 36? Alrighty, 6, 12, and negative 36, the GCF would be 6. Again, and if you still struggle with GCF, kind of doing it in your head, you're more than welcome to do a factor tree. It's whatever you're comfortable with. Then we have the greatest common factor of our variables of a. We have a cubed, a squared, and a cubed. So again, it's kind of like if you would see it like this. We have a, and a. Then we have 2 A's, then we have 3 A's again. Okay, how many A's do they all have in common? This one has 2, this one has 2, and this one has 2, so that's how I got a squared. Same thing with the C's. All 3 of these C's only have 1 C in common. Then your final product is when you multiply all of the coefficient and then the variables together. That is how we got the GCF of 6a squared and 6a squared C. So I think the only tricky part here for you guys is going to be the GCF of variables with exponents. Alrighty, now we're going to factor polynomials. So the first step is find the GCF. The GCF of this particular binomial is 9x squared y. Then you're going to divide each term of the original polynomial by the GCF. Then put your answer in the form of two products. So it's going to look like this. So my GCF up there was 9x squared y. I'm going to divide each of those terms by 9x squared y. I'm going to divide here. That's going to give me y squared in the first one, plus, because of the addition sign right here. 54 divided by 9 is going to give me 6. X cubed divided by x squared is going to give me 1x. Y divided by y is going to cancel out. So this is our quotient, right? Alrighty. So we're going to put our quotient in parentheses, just like this. We can't forget about our greatest common factor. So we put our greatest common factor smack dab right on the outside of the parentheses, just like that. To check your work, all you would do is you would distribute this term to each term, and you would get this original product. Okay? That is all you do there. I know it seems like a lot. It's really not that bad. Okay? All right, I want you to try this. X cubed plus 2x squared. First thing, find the GCF, then divide the GCF by each term in the polynomial. Then put your quotient in the parentheses, put your GCF on the outside. Hit play when you're ready to find the answer. So my final answer here was x squared in parentheses x plus 2. Alrighty. All right, let's do this one together. 28x to the 5th, 70x cubed. So the GCF of 28 and 70 is going to be 7. That's our coefficient. GCF of the coefficient. Then we have x to the 5th plus x cubed. Okay? How many x's do they have in common? We have a max of 5, a minimum of 3. So we always go with the minimum. So that's going to be x cubed. Parentheses, we're going to divide each term by the GCF. Okay, that's going to give me 4x squared plus, because this is an addition polynomial. 70 divided by 7 is going to be 10. X cubed divided by x cubed is going to be 0. So this is our final answer. All right, this one is exact same steps. It's just going to take it, it's just a little bit longer of a, it's a trinomial. So instead of a binomial, it's going to be one extra step there. Okay, same thing. GCF of each term is 10, 25, and negative 5. The GCF is going to be 5 for the coefficients. Let's put that up here. We have a cubed, a squared, and a squared. That's going to give us the GCF of the a's will be a squared. It's the minimum amount of a's we have in common. Now let's hit our b up. We have 3 b's here, 3 b's here, 1 b here. We only have 1 b in common, so that's going to go there. Divide each term. So we're going to do 10a squared b, or sorry, 10a cubed b cubed divided by 5a squared b. 10 divided by 5 is going to give me a positive 2, or a whole number of 2. A cubed over a squared is going to give us 1a. B cubed over 1b is going to give us b squared. We have addition sign next, so we're going to do addition. Then I have 25a squared b cubed over our GCF. It's going to give me a 5. A squared over a squared is going to cancel out completely. B cubed over b is going to give us a positive b squared. We are now subtracting. So we're going to have 5a squared b over 5a squared b. These are all going to cancel out. It's going to give us a whole number of 1. And this is your final answer right here in the blue. Okay? Alrighty. A prime polynomial is a polynomial whose terms do not have a common factor other than 1. So right here, 27 and 35 only share a common factor of 1. And there's no y factor over here. There's only one y. So this is a prime polynomial. Okay, you won't see too many of those, but you will see them. Alrighty, in your notebooks, I want you to try these numbers 1 through 9, all of them. Okay, show your work. First find the GCF, then divide each term by the GCF, then finish off with the end result. Okay? Alrighty, if you have any questions, I will answer next time in class. Good luck, and I'll see you next time, guys.